Hello everyone, welcome to new class. Today's class is about transistors. The transistor was invented by William Shockley, John Bardeen and Walter Brattain, and the term transistor is derived by contracting the words transfer resistor, transfer resistor, and the transfer of current here takes place from low resistance to high resistance circuit, and this transistor has replaced vacuum tubes in almost all applications. Next is bipolar junction transistor. The bipolar junction transistor is constructed with three doped semiconductor regions separated by two p-n junctions. So these are two p-n junctions and the three regions are called emitter, base and collector. And there are two types of bipolar junction transistors. One type consists of two n regions separated by a p region, that is NPN, and the other type consists of two p regions separated by n region, that is PNP, and the PN junction joining the base and the emitter region is called the base emitter junction. So the PN junction joining the base region and the emitter region is called the base emitter junction, and the PN junction joining the base region and the collector region is called the base collector junction. So a transistor has three doped regions: emitter, base and collector, and all these regions are provided with terminals. Let us study about these regions. First one is emitter. The left hand region of the transistor is called emitter and is heavily doped than the other two regions, and its main function is to supply majority carriers to the base. The emitter is always forward biased with respect to the base. Next is base. The narrow central region of the transistor is called base. The thickness of this region is very thin and is very lightly doped. Next is collector. The right hand portion or the right hand region of the transistor is called collector and it is moderately doped. The collector region is always reverse biased with respect to the base. The arrow in the circuit symbols of the transistor indicates the direction of the conventional current flow and can be used to differentiate the NPN transistor from a PNP transistor. So this is the symbol for NPN transistor and this is for PNP transistor. Next is about the transistor operations. So if the emitter junction and collector junction is forward biased, then the region of operation of the transistor is called saturation. And the transistor acts as a switch in this region. Next is if the emitter junction is forward biased and collector junction is reverse biased, it is called active region of the transistor. And the application is the transistor acts as amplifier in this region. Next is if both emitter junction and the collector junction are reverse biased, then it is called cut-off region. And here no current flow occurs That is, the transistor is in off position. And if the emitter junction and collector junction are, that is, emitter junction is reverse biased and collector junction is forward biased. So the inverse of these region, that is active region, it is called inverse active region, and it is not used in practical cases. So these are about the transistor operations. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.